Hey guys, and welcome back to another lesson on the R programming language. So here I am in the R studio, and today we're going to talk about vectors. Vectors are the most basic R data object, and there are 6 types of vectors. They are logical, integer, double, complex, character, and raw. These are the data types that we talked about in previous lessons. And when it really comes down to it, those were all just single element vectors. So again, so how do you write a vector then? Is as simple as setting x equal to some value such as 2, and now we have a single element vector. All right, but usually and through standard convention, I suppose, you will see a vector being created like the following. X equals C, and C is a function, and C stands for combine, I believe, where it combines the elements together within C. So the parameters here, I can do something like 1, 2, and 3, and so now I have a vector that has 3 elements in it. All right, so that's all great. That's all good and dandy. The vectors also, all of the elements will be the same data type. So what do I mean? I can create a vector such as x equals c, and then 1. Uh, let's do, okay, you know what? Let's keep this same example here first. Print x. Let's see uh, what the class is. So let's see what the data type is. So we just have to print class x, and we can see that this is a vector of the numeric data type. All right. So now what I'm going to do is I'm going to change this to 1, 2, and 3L, which means that that 3 is an integer while these other two are numbers. And enter here. And then let's print to see what x is. It should still be numeric as it is. Perfect. Um, let's try something a little bit, a little more obvious. So let me put in a logical data type, like true. Let me put in a integer data type such as 2L. I will also put in a numeric data type such as 3.5. I will put in a character data type such as hello. All right, and let's print x. So we see we get true, 2, 3.5, hello. That was the vector that we were expecting. Now, what is this vector's data type? Well, let's print it out. It should be a character. Okay, so perfect. So we see that it is a character, but why is that when we put in numbers, we put in um, the logical data type? Well, it seems that, of course, if you have a vector, all of the elements must be the same. That's number one. But then the priority of what the element is basically boils down to what the data types are that's in there. So let's give another example. Let's set x equal to this. True, 2L, and 3.5. So we got rid of the character data type within the vector. So now our data type of our vector should change as well. So let's see. What will that data type be? To me, it looks like it's going to be numeric. All right, so let's go ahead and enter this, and we see that we get the numeric data type. All right, so let's give another example. Let's get rid of that numeric data type, and let's put true and 2L. So true is the logical data type, and 2L is an integer. So now our vector's data type is an integer, and we see that here. And then I guess you know what? You might want to see that yourself. So let's go ahead and print out what x equals now. And we see that x equals 1 and 2 because true, our logical data type, evaluates to 1. Okay, and let's change true to false so that you can also see what that data type basically evaluates to, which it should be 0. And so now we get 0 and 2. All right, so our data type for x in this case is still an integer. Alrighty, and now let's get rid of the 2L and let's see what our data type is now. So our data type, we are passing in false. So our vector's data type should now be logical. So let's print. We see we print out false, and the data type is logical. Okay, perfect. So let's do a few more things with the vectors. Let's see, I want a vector of nothing but logical data types. So I will put true, false, false, true. That should be good enough. And of course we can print this and we see we get true, false, false, true. And then maybe we want a vector of all characters. So we could say hello world and then exclamation point. And we can print this and we see hello world exclamation point. Okay, something else that we might want to do is a sequence of numbers for a vector. So we can set x equal to something like the numbers 1 to 10. And that's how we do it using the colon notation here. And let's print out x. And we can see that it prints out and sequence the numbers from 1 to 10. All right, and let's see, let's set x equal to a vector from 1.1 to 12.1. All right, and let's print it out and let's see the sequence. And you see it increases by 1 and the sequence still follows. Now, something to kind of notice here for the next example is I'm going to change this dot 1 after the 12 and let's see what the sequence looks like after I change that. So I have 1.1 colon 12 point, let's do 12.8. So let's see what happens. What you'll notice is that the 12.8 got omitted. So it's not there because that ending value did not follow this sequence. So that's something to be aware of. And I think that this is where I'm going to end the video on vectors. So thank you all for watching, and I'll see you all in the next video lesson.